My name is Andrea Coronado. I'm the Development and Communications Director for Tip of the Mitt Watershed Council. And I am just going to quickly share my screen. Hoping you guys can see that. Again, my name is Andrea Coronado. I'm going to be facilitating today's Icebreaker series. We have over 150 people registered for today's presentation. So when we get to the Q&A portion of the program, we may have to limit questions to keep to our presentation to an hour. I want to thank you for joining us for today's Icebreaker. This is the second in the series for 2024, and we will be hosting this series every other Thursday at noon through March. This Icebreaker series is free to our community thanks to the generosity of our members and donors. I'm sure many of you are in the audience today, so thank you so much for your support. For those of you who are new to the Watershed Council, we are an environmental membership-based nonprofit celebrating 45 years of protecting and caring for our water resources in northern Michigan. And with the help of many, we work to preserve the truly irreplaceable lakes, rivers, streams, and waters that make northern Michigan so unique and special. We work locally in watersheds within Antrim, Charlevoix, Sheboygan, and Emmett counties, and throughout the Great Lakes Basin. So just a little bit of housekeeping today. We will have all attendees muted during the program just to avoid any background noises. If you have a question, please use the Q&A function, not the chat function. We will answer those questions at the end unless there's something timely that I can chime in and ask Christian as he's speaking. If we don't get to your question due to time constraints, we will follow up with you individually, or you're welcome to contact us at the Watershed Council. You can message each of our staff members directly from the website. We'll also be sharing Christian's contact information as well. Lastly, this webinar is being recorded. We'll have it available on our website, and it'll be posted on Facebook as well. There'll be a survey at the end of the presentation, and we really, truly would appreciate your feedback. As always, virtual technology can go wrong, so if we experience any technical difficulties during this presentation, we really appreciate your graciousness and patience as we work out any glitches. I am thrilled to introduce our speaker, Christiaan Bon. Christiaan is a Senior Geologist in the Remediation and Redevelopment Division of the Michigan Department of Environment, Great Lakes, and Energy. He serves the public as a geologic expert on sites of environmental contamination. His expertise includes assessing PFAS contamination sites, leaking underground storage tank site closures, brownfield redevelopment sites, Part 201 compliance, Part 213 compliance, CERCLA process, and vapor intrusion assessment. He is currently the Regional PFAS Lead for the Gaylord District and previously served as vapor intrusion point of contact. So thank you, Christiaan, for joining us today, and I'm going to stop sharing my screen and turn this over to you.
Okay, hopefully you can see my screen. Did I share the correct screen?
I believe so.
Okay. So yeah, thanks for having me today. I wanted to create a presentation for a wide audience today. I know we have scientists with Tip of the Mitt Watershed Council, and we have members of the general public. So I'll have high-level information, basics, and everything in between. So I'll first discuss PFAS and some of the health effects. So what are PFAS? PFAS are a class of man-made chemicals that includes thousands of PFAS compounds. You may have heard of PFOA and PFOS. Those have been in the news. Those are two types of PFAS in the class of PFAS. They have strong carbon to fluorine bonds. They have one of the strongest bonds in chemistry. They act as surfactants, are highly stable, and they repel water, oil, fat, and grease. Surfactant may act as a detergent, a wetting agent, an emulsifier, a foaming agent, or a dispersant. Also, they don't like water or oil, rather the interface between. Industry began developing PFAS compounds in the 1940s, and really they've been unregulated since very recently. Due to this, there's concern because they're widespread in the ecosystem. They don't break down easily. They're hard to get rid of. Some bioaccumulate, which means they build up in the bodies of humans, fish, and wildlife. And some biomagnify, meaning they build up in the food chain. Some PFAS may affect health, and there's a lot we don't know yet about PFAS. There's emerging science and information that comes out all the time. And there's a lack of federal standards, but the EPA is working on that, and they expect their standards to be out in the first part of this year. PFAS have many uses. They are used as treatments on many products, from food packaging to furnishings, because they are so good at repelling oil, fat, grease, and water. So they're used in clothing and outdoor gear as waterproofing, on car seats as stain proofing, and they're used in cookware to keep food from sticking to pans. And they're used in many household products to make them, more useful to humans. They're also excellent at fighting petroleum fires because they separate a fuel source from air, extinguishing petroleum fires very rapidly. And they're used in many protective coatings. So how does exposure to PFAS chemicals occur? Mainly from drinking contaminated water, and that's the main route of exposure we try to stop at EGLE and at MPART. And exposure can also occur through eating fish caught from water contaminated by PFAS, mainly near sites of environmental contamination. And we have Eat Safe Fish guidelines with recommended servings of fish for these bodies of water. Incidental swallowing of contaminated soil or dust can also occur. Eating food packaged in materials containing PFAS can cause exposure, and using some other consumer products in our homes can cause exposure as well. PFAS absorption through the skin is typically not a concern at low concentrations. And health problems are not immediate. So if you drink water with high levels of PFAS, over time you could be more likely than the average person to develop some health problems in the future. This chart shows blood levels of the most common PFAS in people in the United States from 2000 to 2018. Since 2002, production and use of PFOS and PFOA in the United States have declined, as has the use of some PFAS. As the use of some PFAS has declined, some blood PFAS levels have gone down as well. However, as PFOS and PFOA, you can see the green line here, PFOS and PFOA, the blue line, as they are phased out and replaced, people may be exposed to other types of PFAS. And PFOA and PFOA half-lives are very long. It takes a long time to rid the body of these compounds. PFOA has a half-life of 2.3 years. That's the time it takes for half the concentration in your blood to be expelled from the body. So what are some of the associated health outcomes? Reduced fertility, high blood pressure or preeclampsia in pregnant women, small decreases in infant birth weight, higher cholesterol, thyroid disease, liver damage, decreased immune system response to vaccines, and developing certain types of cancer, in particular kidney and testicular cancer with PFOA exposure, have been some of the linked health outcomes. But new research keeps coming out on new health outcomes associated with PFAS. So in Michigan, how are PFAS sites discovered, and how do we protect public health? And this is done in Michigan through the Michigan PFAS Action Response Team. MPART is Michigan's body that was created under an executive order to ensure the 7 state agencies working on the PFAS response are coordinated. MPART also coordinates with the federal government on several programs and projects. And when we get to the project level, MPART partners with local officials. We believe that the MPART communication structure is the reason that we've been so successful at rapidly identifying PFAS exposures, communicating with the general public, along with using a data-driven, scientific-based approach. So here you can see the 7 agencies that are responsible for the different parts of PFAS in the environment. The Michigan Department of Agriculture and Rural Development, Department of Natural Resources, Michigan Department of Transportation, Licensing and Regulatory Affairs, Department of Environment, Great Lakes and Energy, which I am a geologist within EGLE, Michigan Department of Health and Human Services, and DMVA, who's in charge of military sites. And then a big piece that's not a state agency, but a big piece of the puzzle is our local health departments. And all are using a science-based, data-driven approach to understand the occurrence of PFAS in our environment, identify PFAS sites, reduce source concentrations, and stop exposure to protect public health. Now, I always love this diagram. This diagram shows 2 things, how PFAS are cycling through the environment and 2 places that Michigan is sampling. So to demonstrate how PFAS are cycling through the environment, starting in the left, we have a PFAS producing or using industry. And they may be discharging wastewater to the ground or to rivers or to wastewater treatment plants for their sanitary sewers. And once this wastewater ends up in rivers, it may affect fish, or if it ends up in groundwater, it may be taken up as drinking water, as a drinking water source. Or if PFAS ends up in a wastewater treatment plant, these wastewater treatment plants are not designed to treat for PFAS. So wastewater treatment plants may discharge PFAS impacted and treated water to rivers. They also accumulate organic matter, which those sludges may go to a landfill, and landfill leachate is also processed at wastewater treatment plants. Or those organics may be applied as biosolids on farmland, where they may end up in food products or leach rainwater to the ground and contaminate groundwater. Again, drinking water uptake occurs from rivers, lakes, and groundwater and may impact people. And food products can also impact people, as well as air emissions. The second reason we talk about this diagram is that we are sampling at all of these points, all of these places. We're doing research on farmland. We are sampling landfills. We're sampling wastewater treatment plant discharge, sampling discharges from industry, and looking for PFAS sites that may be impacting rivers and groundwater. EGLE also conducts investigations to determine sources of PFAS. For example, elevated surface water sampling results or elevated fish results will result in additional investigation to ideally find the source of PFAS. Then staff work with the tools we have to get the discharger to address the PFAS at the source and stop the cycling of PFAS through the environment. EGLE has had initiatives focused on several sectors. Airports, mainly due to $15 million appropriated to assist airports with investigation due to the use of aqueous film-forming foams, or Class B AFFF. Wastewater treatment plants, due to industrial pretreatment programs where they sample sludges and wastewater. Active landfills, due to the monitoring wells that are already present at landfills and the sampling of leachate that occurs at landfills, and military bases due to the heavy use of and training with AFFF, Class B AFFF at military bases. So here you can see Michigan standards. So on the left, if we get a drinking water sample, we compare to the drinking water and groundwater cleanup standards. And on the right, if we get a surface water sample, we compare to the water quality values. You'll notice these are in parts per trillion. So 1 part per trillion is very close to 1 drop from an eyedropper in an Olympic-sized swimming pool. So very, very, very tiny amounts. And commercial labs only recently have been able to detect compounds at these levels. So it really is an emerging science. You'll also notice that water quality values for drinking water sources, such as the Great Lakes or some rivers, have a lower water quality value. So Michigan has 275 sites that exceed Part 201 criteria. So that's each one of these purple dots, and these are all of our Michigan PFAS sites. So to be a PFAS site, you need to have a groundwater sample that exceeds the standards I showed on the last slide. We've prioritized investigations based on known or suspected sources and the potential for exposure through drinking water. And our main goal here is to protect the drinking water pathway. And there are many other investigations underway. This is only showing those sites where we've exceeded criteria, but there are many other investigations that have not resulted in a sample that exceeded our drinking water or water quality standards. So this is a little bit older, showing 266 PFAS sites from last year. But you can see that landfills really dominate a good chunk of the pie chart. So 90 of our PFAS sites are landfills, and this is primarily due to the landfill initiative. That initiative started with sampling solid waste landfills with drinking water receptors nearby and already known groundwater contamination. So those were high priority. 70% of those high priority solid waste landfills became MPART sites. Now that the high priority landfills are sampled, EGLE is picking away at the medium priority landfills where there's known groundwater contamination, monitoring wells are present, but there's no known drinking water receptors nearby. There's no private wells nearby, and there's no municipal wells nearby or community wells nearby. You can also see here that there's many industrial sources. You can see platers make up a good chunk of the pie. Plating involves fume suppressants to protect workers, to keep them mainly from breathing in hexavalent chromium fumes. The issue is that those fume suppressants can end up in the waste stream of a plater and cause groundwater contamination, or that waste stream may be discharged to a wastewater treatment plant. Airports and military bases make up a good chunk of the pie as well, and this is due to the extensive use of AFFF in training and for putting out aircraft fires. We also have wastewater treatment plant making up a significant portion of this pie. That's because wastewater treatment plants, like I said before, they take in water from businesses and industry and from homes, many of which use PFAS products. So when we investigate sites, we look at a known source. The strength of the source is a big piece of the puzzle, and the local geology. We try to see where wells are situated near a source, what the aquifer is like. Are the wells deep? Are they shallow? And then once we look at all of those factors with the local geology, we determine groundwater flow direction, and then set up a sampling area down gradient or down the path of groundwater flow. Here, the groundwater flow direction is towards the lower right-hand side of the screen. And as you get away from a source, the PFAS concentrations also decrease. And as you move away from the center of a plume, the PFAS concentrations also decrease. So this is the general shape of a contaminant plume. And once we have a lot of residential samples, the plume shape becomes very clear and will lead us to do additional investigation. So what makes MPART unique? And it's the process for making new MPART sites. When EGLE receives PFAS data above groundwater criteria, that data is shared with MPART agencies. A project team is formed between EGLE, DHHS, and local health, and may also involve other agencies like DNR if deer sampling is needed, or MDART if agriculture is involved. We evaluate the data to determine if residential well sampling is needed. Again, we look at the local geology and we look at the strength of the source to determine a sampling area. And then health staff develop a plan for results. Example for, who gets filters. A site investigation summary is created for the MPART website. That summary is shared with local officials, tribes, and legislators prior to posting on the web, and an offer is made to have a conference call to discuss the investigation. We'll hold a local official call if it says if requested, but I haven't had a site where a local official call wasn't requested. And then we'll hold a town hall meeting with the community if it's requested. Most of the time, if homes are impacted, if drinking water is impacted, we'll have that town hall meeting requested. Then the site write-up is posted on MPART website. DHHS determines if res well resampling is needed. They usually do that on an annual basis. And this is to determine if there's any fluctuations in PFAS levels. And then EGLE staff oversee infrastructure funding, such as connecting wells to an existing municipal supply. Something else that made Michigan unique is in 2018, Michigan led the nation by sampling all community water supplies around the state. So each one of these blue dots is a community water supply that was sampled. These include schools, they include businesses, and they include municipal supply wells. And this is available on our PFAS website. And I'll post that website link later. So over 1,600 community water supply samples in 2018, and then compliance sampling afterwards. And of those samples, 85.7% were non-detect for PFAS, so no PFAS was detected. In 13.1%, we had detections that were less than the drinking water standard, or the maximum contaminant limit, MCL, and 1.2% had detections greater than the PFAS MCLs or drinking water standards. And this 1.2% is taking action to address PFAS, such as putting carbon filtration on their drinking water wells, or drilling new wells in areas that aren't contaminated. This same GIS also includes surface water samples with these green squares, and you can also view information on PFAS sites in your area. So those are indicated by the purple triangles. So if you're in an area or you live up here and you're wondering, what sampling has been done nearby, this is a great tool to get started. And each time you click on a purple triangle, you can go to the site write-up for an MPART site, or data will pop up that shows you what those levels were, what the detections were, if there were any, in those watersheds. And the surface water data is updated annually. So outside of those prioritized investigations I talked about, your airports, your landfills, your military bases, and wastewater treatment plants, how else do we identify possible sources of PFAS? And one way is through lake and stream sampling. So in 2023, EGLE collected 504 water samples from 45 different watersheds. And EGLE rotates through the state's watersheds on a 4-year rotation. So all watersheds are sampled. And this is in addition to site-specific water sampling that's done. Many of my projects, I don't rely on our watershed sampling team. We have our contractors go out and collect surface water samples. And Michigan has a big advantage over many other states because we have criteria in place for surface water. We also collect fish. So we've collected yearly. We collect over 1,000 fish and sample them for PFAS. And this shows all the different PFAS analytes and the average percentage of the total PFAS. So I remember I said PFAS are a class of compounds. This shows all the different compounds that have been detected and the percentage of the total PFAS. So you can see that PFOS really predominates in these fish. PFOS bioaccumulate in fish tissue at a higher rate than other PFAS. And this is one of the reasons why PFOS has the lowest surface water criteria at 12 parts per trillion. And it really becomes a driver for our surface water investigations. It also has a very low drinking water standard at 16 parts per trillion, and thus is a driver of many of our groundwater investigations as well. We have a lot of hunters in our area, so I wanted to touch on some of the deer sampling that's been done, or all of the deer sampling that's been done in the state of Michigan. You may have heard of the Do Not Eat advisory near Clark's Marsh, near former Wordsmith Air Force Base. And in 2018, 20 deer were sampled near Clark's Marsh. 19 of those deer were non-detect or at very low levels of PFAS. One deer had 547 parts per billion of PFOS. So this deer was likely spending a lot of time in this marsh, drinking its water, and eating food out of this marsh. In 2019, the DNR tested 22 more deer. No PFAS was detected. In 2020, DNR tested 44 more deer. Deer had detectable levels, and the data suggested that deer closer to the marsh were more likely to have PFOS, and it really accumulated in the liver of those deer. In 2021, the DNR reduced that do not eat advisory to a 3-mile radius, and an annual press release is issued about that advisory. Now, that's not in tip of the Mitt service area, but this is an area of very, very high contamination, this Clark's Marsh, and you can see that it does affect the wildlife that spend time in that marsh. In other areas, in 2017 and 2018, deer were sampled statewide, and they had no or very low PFAS detections. In 2018, we had a more site-specific study looking near 2 of my sites, Alpena CRTC and Camp Grayling, as well as Rockford. And 20 deer each from those sites had no or very low detections of PFAS. It did not warrant any guidelines. And in 2019, the DNR sampled 20 deer from Proud Lake Rec area due to high PFOS found in fish collected from Kent Lake, but no PFAS was found in any muscle or heart samples, and no guidelines were needed there. So it looks like in a very highly contaminated marsh, that's where we're seeing, these very high levels of PFOS in deer. I quickly wanted to give you a high-level view of PFAS sites in the tip of the Mitt service area and how sites pop up for the Gaylord District. A highly impacted site in our district is Pellston Regional Airport. So first I'll talk about the EGLE investigation. Pellston Regional Airport had past use and training with aqueous film forming foam. We had a sample in 2020 that came back with high levels of PFAS above our drinking water standards. And within a week, we were out there to verify that private result. We did confirm that result, and the following week we had a town hall and established a residential drinking water sampling area. which really encompassed the entire village and everything to the north of the west branch of the Maple River. We've collected 219 samples, residential samples. 59 exceeded, with the majority of them directly downgrading of the airport. We've had 68 detections and 92 non-detect results. We do see a small area of detection. Most of those are PFOA detections, a few above criteria. And this is indicative of possibly some other very low-level sources, and our PFOA drinking water criteria is so low that when it's detected, many times it's above criteria, our criteria of 8 parts per trillion PFOA. That's only 6 parts per trillion above our reporting limit for a lab. So extremely low concentrations trigger that red dot. Resampling has been done in this area 3 different times, and DHHS is getting ready to do another round of resampling in 2024, I believe next month. And point of use filters have been given to any home with detections. So after receiving many of these residential results, we've done vertical aquifer characterization to delineate PFAS extent. And vertical aquifer characterization is when we drill down to 100 feet below ground surface and then take a water sample every 20 feet to get a good idea of where PFAS is below the ground surface. So here we're showing the highest result from each of these locations. The red dots exceed. The yellow are detections, and green are non-detect. So our areas of non-detect are where we'd expect on the opposite side of the west branch of the Maple River, and in areas not directly down gradient of the airport or some of this unknown low-level sources that I talked about in the village. And this really established a remedial area for drinking water. That remedial area is likely going to need a public water supply. So we've started looking at different locations where we could put a drinking water or a public drinking water supply well. We've proposed some different areas, and we've drilled in 2 different areas now. We did this work last fall before the snow started to fly. And then we had an area where we had some difficulty drilling because there's a lot of moraine material with large boulders and highly compacted clays. That's very difficult to drill through and probably wouldn't produce much water. So that's likely not a good location for a public supply well. These 2 locations will likely be considered for a public supply well, or those areas would be. And we've taken water quality characteristic samples for things like iron and calcium, hardness of the water, to make sure we know if any pre-treatment would be needed for water before it's distributed through the system. And this helps with creating estimates for a future supply. We've also done extensive surface water sampling in the Burt Lake watershed. These are results from 2020. You can see most of these results are non-detect. The Sturgeon River was non-detect. The Indian River was non-detect. Burt Lake was non-detect. The Crooked River was non-detect. The East Branch of the Maple River was non-detect, and the upper West Branch of the Maple River was non-detect. But downstream of Pellston, we did get detections, very low detections, 1.2, 1.1, and 1.4 parts per trillion that didn't exceed our surface water criteria of 12 parts per trillion. So no actionable levels, but things to continue to monitor. Because we know that PFAS impacted water may be impacting the west branch of the Maple River, we also took fish tissue samples because local fishermen eat brook trout from the west branch of the Maple River. We had a sampling location upstream of Pellston Regional Airport where 5 parts per billion of PFOS was found in brook trout, and a location downstream of Pellston Regional Airport where 14 parts per billion PFOS was found in brook trout, so a little bit, quite a bit higher downstream. Yet no update to the existing consumption of brook trout in that Eat Safe Fish guideline was warranted. We didn't update that advisory because there's already a consumption advisory, a statewide consumption advisory for brook trout for mercury. And you might say, why mercury? And it's due to past burning of coal that has caused widespread mercury deposition throughout the United States, mainly before any remediation was done or any scrubbers were put on the emissions of coal plants and other industrial sources. Pellston Regional Airport has also done their own investigation, mainly through 2 MDOT EGLE grants that were awarded to the airport, totaling over $500,000. And these identified source areas, areas where they trained with AFFF, established monitoring wells, established the groundwater flow direction through sampling those monitoring wells, and established concentrations of PFAS emanating from the airport. So this is where they believe this plume from a few different sources, training areas, and fire responses at the airport. The airport on its own has also done additional soil investigation to determine what are the source concentrations in soil so that they know how to handle the soil when it needs to be moved. They replaced an apron in front of some of the where the planes park. That's the apron of the airport. So this soil had to be handled. They didn't want to create a new area on site where PFAS could leach from that soil and cause additional groundwater contamination. So they encapsulated that soil on site or locked it up in different materials. Pellston Regional Airport has also done a pilot study of plume stop. Plume stop is a very fine carbon that's injected into the ground. So here you can see a drill rig that drills holes, and then they use equipment to inject that carbon product into the ground. This is done in a 30 by 20 foot area. This is a very small area that they do at first because they want to make sure, one, that it works before you go to full scale implementation, but also that there's not any unintended consequences. It did work very well. In the area that it was injected, there was a 95% reduction in PFAS. But there are some concerns about migration of plume stop down gradient. We didn't inject very much, and we saw it move a little bit, not to any homes in this area. But the concern is that when you go full scale, you inject more, that there is the potential for migration. You don't want to be discharging discolored water to the west branch of the Maple River or find discolored carbon impacted water in residential wells. That wouldn't be a solution to the issue that we have. So, the data is transferable to other carbon products that maybe don't move as much. Another option is injecting additional plume stop closer to the sources, or inject after municipal water is available, because then you won't impact any residential wells. So Pellston's next steps, the Village of Pellston has an $835,000 grant to look at alternate water options. So funds can be used for anything up to the construction of a municipal system, including well field locating, which we're helping with to offset some of those costs. Put in test wells, do permit applications, develop blueprints, etc. And the idea is to have them well positioned for future grants to build a municipal water supply. But education on public water will be needed to make sure everyone hooks up and everyone is not exposed through drinking water anymore. And everyone can get off these point of use filters, which are a temporary solution. The airport's going to continue delineation, expanding the remedial approach, and managing on-site conditions. And EGLE is going to continue reviewing airport response activity plans. Any work that they do needs our approval. And we'll continue to fill data gaps. We did a large off-site investigation, and we'll continue to fill in data gaps as needed. And we'll continue to process new drinking water sample requests. There's still homes in this area that haven't been sampled. We'll continue to honor those requests and make sure we know that we give everyone filters that needs filters, and everyone is part of that remedial option that needs to be part of that. So airports are like a priority site. I talked about those priority sites, but how are other sites? How do they become MPART sites? We have other sites where there's established monitoring well networks for a different contaminant. In this case, at Charlevoix Municipal Wellfield, this was an EPA-led Superfund site that was started in 1981. They've done a lot of remediation. They've done excavations, they've done injections to remediate, and they've done mitigation on homes for vapor intrusion in this area. So there's an established network of wells, but the same sources that cause the TCE and PCE contamination, dry cleaners, and a couple manufacturing sources, also have the potential to be PFAS sources. So EGLE offered to conduct PFAS sampling since EGLE was better suited to facilitate the sampling in an expedited manner. The highest results for 15 parts per trillion PFOA, 200 parts per trillion PFHXS. So the PFOA is here, PFHXS was here. Municipal water is available here, and due to this being a Superfund site, everyone is connected to municipal water, so that's great news. And those levels of PFAS are below our surface water criteria. So in this case, we know that surface water receptors are not impacted. We know that drinking water is not impacted. So this will continue being an EPA-led Superfund site following the CERCLA process, and they'll continue to get this site to closure through remediation and monitoring. So that was another way that PFAS sites come into our district. The Key 2 industrial building came in a different way. This is an Elk Rapids site and is a former manufacturer. So sites also come to us through due diligence work by prospective buyers. So anytime someone buys a commercial or industrial property in the state of Michigan, they're required to do a phase 1 environmental site assessment where they look at the environmental history of the site. They're looking also, an environmental professional goes to the site and does a walkover, and they determine if there's any reason that they suspect a release could have occurred of any hazardous substance at the site. In this case, there are past plating operations, and I mentioned earlier that fume suppressants are used in plating, and that may have caused a release. So they sampled for PFAS at the site as well as other contaminants. And the highest level found was 160 parts per trillion PFOS and 24 parts per trillion PFOA. Adjacent to that, PFOS levels are much lower. This is 13 parts per trillion. And then outside of that, non-detect PFOS. So not a large source. When we talk about our AFFF sources, like at Pellston Airport, you're talking parts per billion range. Orders of magnitude higher than this over a wide area. And in this case, it's a very small area. Municipal water is available here. So even though we exceed our drinking water criteria, no drinking water wells are impacted. And then we have quite a distance from surface water receptors. And so we don't believe that a concentration like 160, we see that already decreasing. If you extrapolate that out, that's not going to reach a surface water. So this isn't an MPART site, but I know this had some attention in Petoskey. This is another way that PFAS may be sampled for. as part of a brownfield site assessment. And the brownfield program tries to redevelop these contaminated sites, making sure they're not exacerbating conditions, making things worse, and making sure that due care is followed, making sure that people are protected when using this property. So here PFAS was sampled due to past use and possibility of release of wood glues in past operations. We know that wood glues can contain PFAS, as well as formaldehyde, which was sampled for. No detections of PFAS exceeded surface water or drinking water criteria. So this makes it not an MPART site. It's not one of those purple triangles on our map. The highest detection was quite low, and we did extensive sampling here at this site. The highest detection was 2.4 parts per trillion PFOA. And when you compare that to 8 parts per trillion drinking water criteria, it's below that, and 170 part per trillion water quality value, it doesn't exceed that. So no actionable levels there for the Bear River and municipal waters available. So this doesn't indicate a source that is impacting receptors. So in our district, we have more sites than this. We have other sites like Camp Grayling, Alpena Hide and Leather, Alpena CRTC. These sites aren't within the tip of the Mitt service area, so I didn't discuss those today. But there's many other sites that we've investigated where we didn't, just like Michigan Maple Block, we don't see high enough concentrations to make it an MPART PFAS site. I want to draw attention here to the michigan.gov/PFAS response. So that GIS I shared, where you can look up what kind of sampling was done nearby, you can look at that site. That can be found on our PFAS response site. Site write-ups of all of our sites are on there. A great place to start if you're just getting interested is our frequently asked questions page on there. You can find a lot of useful information on there, and there's good information on how to get sampled. We sample drinking water wells near known sources, but if you're interested in getting your well sampled, you can do that on your own, and there's information on the site to do that. And with that, I will say thank you. Again, I'm Christiaan Bon. I'm Senior Geologist with EGLE out of the Gaylord District office. I'm PFAS Regional Lead and part of the MPART team. So with that, I will take any questions.
Yeah, thank you, Christiaan. We have quite a few questions in the Q&A function. I'll start just at the top with a question. How is PFAS degraded by microbes in the water and soil?
That's a very interesting question. So right now, one of my coworkers at EGLE is working on a study at Alpena Hide and Leather to look at microbes and how they can break down PFAS. And we want to make sure we're not just breaking down larger PFAS into smaller PFAS compounds, because that doesn't really do us any good. We want to make sure we're destroying PFAS completely. But a lot of that work is looking really good. Like it could be very promising for the future. But it's just really at the investigation scale at this point. It's not widely used yet.
Here's a question. We were kind of talking about this amongst ourselves before we joined this presentation. Is it true that the main cause of foam on the shores of the Great Lakes is due to PFAS? That's
an interesting question. EGLE has done a foam study. So we've looked at some contaminated lakes, Lake Marguerite, Van Etten Lake, and looked at foam composition. And it's telling us not all that foam is PFAS. There's a lot of other things in that foam. There's dissolved organic carbon, there's fungal communities, there's bacteria, and other contaminants in that foam. So is PFAS the only reason we see white foam. I don't think it is. If we have PFAS in a lake, like, I always look at the Lake Marguerite in Grayling. If we do have PFAS in a lake like that, I think it creates more foam. Naturally occurring foam occurs because of dissolved organic carbon. So we already see foam in the spring and fall when we have a lot of runoff. But if you have PFAS as well, I think it causes that foam to be fluffier, whiter, and creates more foam.
Yep.
But if you're interested in that study, that's available to the public. It can also be found on the MPART website or by Googling MPART EGLE foam study. And there's a good write-up that was done by one of our contractors, AECOM, looking at foam.
We had a question from Kelly about how those filters work that you were chatting about and if they can be easily obtained.
Yeah, so the filters that we use is a 3-stage under sink Aquasana filter. So the reason it's 3-stage is because you want that contact time when you're treating PFAS water. It does slow down the rate of water that's coming out of your sink. But we have tested those time and time again, and they've decreased. Every sample we've taken, it shows non-detect results for that drinking water. So it does take all PFAS out of that water, and those can be easily obtained. And there are a number of filters out there that are certified to remove PFAS from drinking water.
I'm not sure if you know the answer to this one, but we have a question from Brian. He's commenting that coal tar driveway and parking lot sealants are full of toxic chemicals that leach into the waterways through sewer systems and runoff. Do you know if coal tar driveway sealants have or contain PFAS?
I think it's highly possible that they do contain PFAS, but I don't believe that that's one of these larger sources. When we go to wastewater treatment plants and we look at sanitary sewer contributions, or we look at stormwater, and we look at contributions from different sources, it really is our priority sites, our manufacturers, our AFFF impacted sites. Once we treat those sites and break that cycle that I was talking about in that other figure, we really drop those PFAS levels considerably. So for us, those are the actionable sites, and those are the ones that make the biggest difference. Yeah.
Hi, Herm. Herm wants to know if PFAS sampling was done on the fish from West Branch of the Maple River and or Burt Lake.
Yep. Yeah, so I did share the results from the West Branch of the Maple River. I'll put those up again. So we looked at brook trout in the West Branch of the Maple River and sampled both upstream and downstream. Not sure if that question was asked prior to me showing that slide, but yep, we have done fish tissue sampling there. As part of the watershed investigations, we'll sample fish for PFAS if we've had foam reports, if there are nearby sources. So I'm not sure about Burt Lake. I would have to contact someone else for that information.
Herm, maybe we can shoot you a quick email about that. With regard to PFAS near the Pellston Airport, were the high levels only on the south side of the airport? Is that where the groundwater flows, or is that simply due to the proximity to the airport, as your map would suggest?
Yeah, let me show this again. So yeah, we know the groundwater flow direction. At first, we knew the groundwater flow direction because we've remediated a gas station on the east side of the airport, and that helped us establish kind of our drinking water sampling areas. But the groundwater flow direction is to the south-southwest from Pellston Regional Airport. So the main area of contamination here and the highest levels that we see are those ones that are directly down gradient in the flow path from those sources at Pelson Regional Airport.
Do you know if there has been any testing at the old Camp Helston site, which is a closed small prison?
I am not sure about that one, but something else that we tested in Pelson, we looked at the township dump. I know we always get questions about township dumps, and this was active in the 70s and 80s, and took general household trash from homes in the area, and we didn't see any PFAS levels above our criteria at that location. So that was really good news there. We had an established monitoring well network from a past investigation there.
This attendee tossed a couple of questions in one spot, so I'm gonna try to get through them. Is there a reason the water is tested at parts per trillion and fish are tested at parts per billion?
Yeah, so it's a unit of measure. So 1 part per billion is 1,000 parts per trillion. As far as water goes, you're drinking water, day after day after day. You're drinking higher quantities of that, and the bioaccumulation of that water makes those toxicity values so that our criteria are very low. When we talk about fish, you're not eating more than a few servings a month of those fish, so your intake is much lower for those fish, and therefore we're looking at parts per billion for those advisories.
Some of these questions I think you answered during your presentation, but there's just some follow-up questions. How much are the chemical companies that manufacture firefighting foam contributing to PFAS testing and cleanup? So are the companies contributing to it? Funding?
It's currently in litigation. So yes, it's currently in litigation.
In litigation. No comment. So is there a difference do you see any differences in PFAS levels between men and women, or is it pretty equitable across genders?
Yeah, that's really a health department question. I am not qualified to answer that one as a geologist.
Okay. All right, we'll move on to David's question. Do PFAS contaminated sites enter vegetable or grain foods, or is it only animal and fish?
I can get you in touch with someone that could answer that question better than I could. But
Okay.
the research is being done. That's really an emerging science, looking at plants, what's going in the fruiting body of a plant versus the leaf versus the roots, and that it is being tested, but I wouldn't know how to compare that to fish and wildlife.
I think you did already talk a little bit about city and township firefighting and training as a sources of PFAS contamination, correct?
One more time, please.
They had just a question about firefighting and training as sources of PFAS. Is that a large contributor?
Yeah, that's going to be something else that we're currently looking at. We've done surveys of all fire departments in the state. So we're aware. We've done an AFFF pickup program from fire departments in the state. So, the first thing we wanted to do is make sure that we didn't have any of this legacy AFFF out there that contained PFOA, PFOS, those PFAS that we regulate. That's step one. Step two is looking at, where was it used? One-time use of AFFF, you're not looking at these very large plumes, but it's certainly something that we've looked at certain sites. There have been some car fires in the state, a tire fire, the Menominee fire where we looked at AFFF contamination. So it's definitely another initiative. It's one of the next priorities.
And we'll finish up with one last question. It's probably on top of a lot of people's minds as they're out there skiing right now in this weather. In the news, there have been high levels of PFAS found at ski resorts. I believe he's mentioning that there's high levels of PFAS, particularly in the ski wax. Have there been any testing done on our ski resorts up here?
Not that I'm aware of. I do know that there's the link between PFAS and ski waxes. At this point, not as much of a priority as some of these other sites that we have. Usually our ski resorts, aren't right next to municipal supply wells. They also have different permitting that they have requirements on. So if necessary, they'll be wrapped into compliance testing and regulatory sampling.
Right. Well, thank you, Christiaan, so much. Very informative, a little bit scary. Always great to be educated on what's going on in our area. Kayla, my colleague, has tossed a few links in the chat feature that relate to Christiaan's presentation. So if you're looking for a specific link, check that chat feature. And I'm going to quickly try to share my screen and hopefully not share my presenter view. But join us for the next Icebreaker Series lecture on February 8th, the weakening of the Clean Water Act and what it means for Michigan's wetlands, with Todd Lossie. And February 22nd, Climate Change, a Global Issue with Local Impact, with Brian Burrows. We're always looking for volunteers. So if you have extra time or energy and would like to volunteer with us, please reach out to us. We're always looking for volunteer stream monitors as well. So give us a ring. And lastly, your membership supports everything we do here at the Watershed Council. So if you're not a member, consider joining. We thoroughly appreciate your support. And thank you so much for joining us today. There'll be a brief survey that pops up as you close your screen. We'd appreciate your feedback to make these lectures better in the future. So thanks so much for joining us, and we'll see you in a couple weeks.
Thanks for having me.
Thanks, Christiaan.